Imagine, just for a moment, that you are standing alone on a high, desolate peak, far beyond the suffocating glow of human civilization. The air is thin, biting, and completely still. Above you stretches the night sky, a sprawling, infinite canopy of glittering diamonds scattered across a sea of absolute, unforgiving black. For thousands of years, our ancestors stood under this exact same dome and felt a profound sense of awe, believing they were looking at a static, eternal map of the cosmos. They believed the universe was vast, yes, but ultimately measurable, a grand clockwork that could be understood, charted, and contained within the limits of human mathematics. Even in the modern era, armed with our most advanced theories and orbital observatories, scientists confidently declared that the universe was roughly 14 billion light-years in every direction, a colossal but finite sphere containing a few hundred billion galaxies. It was a picture that felt enormous, terrifyingly so, yet it was a picture that felt complete. It was a comforting illusion. But then, a machine of unprecedented complexity, a golden-eyed sentinel hurled 1,000,000 miles into the freezing void, turned its gaze toward what we thought was empty darkness. And in a single, blinding flash of infrared light, everything we thought we knew about reality collapsed. Before we descend into the deepest, most mind-bending abyss of cosmic history and uncover the terrifying, beautiful truth about the true scale of existence, please take a brief second to hit that subscribe button, leave a like on this video, and turn on all notifications. Your engagement is the lifeblood of this channel, allowing us to continue exploring the darkest, most profound mysteries of the universe and bringing them directly to you. Now, settle in, turn off the lights, and let your mind expand, because the story you are about to hear will fundamentally alter the way you perceive your place in the cosmos. This is not just a story about a telescope. This is a story about the death of our cosmic illusions and the birth of a universe so incomprehensibly vast, so violently active, and so deeply alien that it borders on cosmic horror. To truly understand the magnitude of what the James Webb Space Telescope has revealed, we must first completely abandon the way we instinctively think about space. We are creatures of the Earth, evolved to hunt on the savannah, to throw spears, to judge the distance to a predator or the width of a river. Our brains are hardwired to perceive space as a static stage, an empty room through which objects move. We look across a valley, and we assume we are seeing it as it is right now. But in the universe, this intuition is a fatal, catastrophic lie. Space and time are not separate entities. They are inextricably woven together into a single, flexible fabric. And light, the absolute speed limit of reality, is not just a beam of illumination. It is a messenger, a ghost carrying the past on its back. Light travels at roughly 186,000 miles per second. It is fast enough to circle the Earth more than 7 times in a single heartbeat. Yet, on the scale of the cosmos, this speed is agonizingly, terrifyingly slow. When you look at the moon, you are not seeing the moon as it exists in this exact moment. You are seeing a ghost, an image that is 1.3 seconds old. When you look at the sun, you are bathed in light that left its nuclear furnace 8 minutes ago. If the sun were to suddenly vanish, we would continue to orbit a phantom star, basking in its warmth, completely unaware of our impending doom for 8 entire minutes. As our gaze pushes outward, this temporal delay transforms from a mere curiosity into a profound existential reality. The nearest star, Proxima Centauri, is a ghost from 4 years ago. The center of our Milky Way galaxy is a ghost from 26,000 years in the past, a time when early humans were just beginning to master the arts of survival. But when we look beyond our galaxy, out into the deep, freezing spaces between the great clusters of stars, we are no longer observing the universe as it exists today. We are reading the torn, faded pages of a history book written billions of years before the Earth even coalesced from dust. The night sky is not a live broadcast of reality. It is a chaotic, overlapping archive of dead moments. Every single point of light you see is a time machine, bringing you news from a different epoch. The sky is a graveyard of epochs, and we are the archaeologists, digging through the light to find the origins of everything. However, the universe does not preserve these ancient messages perfectly. As the light travels across the billions of years, the very fabric of space it is traveling through is stretching. The universe is expanding, and as space expands, it grabs the photons of light and stretches them along with it. This process, known as cosmological redshift, is the ultimate cosmic sensor. Energetic, brilliant blue and ultraviolet light from the earliest stars is stretched, diluted, and shifted into the invisible infrared spectrum. It slips right past the biological limits of human eyes. It slipped right past the mirrors of the Hubble Space Telescope. For decades, astronomers stared into the deepest, darkest patches of the sky and saw nothing but empty voids, believing that the early universe was a quiet, dark, and fragile place. They thought the first stars ignited slowly, reluctantly, taking hundreds of millions of years to build the magnificent galaxies we see today. They believed the universe learned to crawl before it learned to walk. But the light from the cosmic dawn hadn't disappeared. It had simply changed its disguise. It was hiding in the infrared, whispering in a language we could not hear. This is why the James Webb Space Telescope was conceived. It was not built merely to take prettier pictures. It was built to hunt the ghosts that Hubble could not see. Webb is an engineering marvel that defies human comprehension. Its primary mirror, a massive, folding honeycomb of beryllium coated in a microscopically thin layer of pure gold, spans over 21 feet across. Gold was chosen not for its beauty, but for its supernatural ability to reflect infrared light. But to see the faintest, oldest heat signatures in the universe, the telescope itself had to be colder than the deepest, darkest corners of space. It had to be shielded from the sun, the Earth, and even its own internal electronics. So, it was sent to Lagrange Point 2, a gravitational eddy a million miles away from Earth, where it unfolds a massive, multi-layered sunshield the size of a tennis court, forever hiding in its own artificial shadow, waiting in absolute, freezing silence for photons that have been traveling since the birth of time. When Webb finally opened its golden eyes and stared into the deepest, blackest patches of the sky, it did not find the quiet, tentative, fragile cosmic dawn that the textbooks had promised. It found a riot, found chaos, found monsters. The first images transmitted back to Earth sent shockwaves through the global scientific community, triggering a mixture of euphoria and profound, unsettling dread. Webb was detecting fully formed, hyperluminous, massive galaxies existing a mere 300 million years after the Big Bang. To grasp the sheer, impossible heresy of this discovery, you must understand the timeline of the cosmos. If the entire 13.8 billion-year history of the universe were compressed into a single calendar year, the Big Bang happens at the stroke of midnight on January 1st. The Earth does not form until early September. Human history occupies the last fraction of a second on December 31st. According to every established model of cosmology, the universe in early January should have been a dark, chaotic fog of cooling gas. Gravity was supposed to be working slowly, patiently pulling matter together over vast, unimaginable eons. The first galaxies were predicted to be tiny, dim, irregular smudges of light, struggling to hold themselves together. But Webb saw giants. It saw colossal, structured, blazingly bright galaxies tearing through the primordial dark. Some of these universe breakers, as stunned astronomers began to call them, contained hundreds of millions, even billions of solar masses worth of stars. They were forging new stars at a violent, ravenous rate. This was not a slow, gradual awakening. This was a cosmic explosion. The universe did not ease into complexity. It violently erupted into it. The cosmic clock was shattered. But the sheer size and brightness of these early galaxies was only the beginning of the nightmare for standard cosmological models. When Webb spectrographs split the light from these ancient behemoths, they found the chemical fingerprints of heavy elements: carbon, oxygen, nitrogen, and iron. This is a profound, reality-altering discovery. The Big Bang produced only hydrogen, helium, and a trace of lithium. Nothing else. Every heavier element in your body, the calcium in your bones, the iron in your blood, the oxygen in your lungs, was forged in the nuclear crucible of a dying star. For these heavy elements to exist in a galaxy just 300 million years after the dawn of time, it means that an entire generation of massive, ancient stars must have already been born, lived out their violent lives, and exploded in cataclysmic supernovae, seeding the void with the building blocks of planets and life. The universe had already gone through multiple cycles of creation, destruction, and rebirth before it was even out of its infancy. The timeline of cosmic evolution was not just pushed back. It was completely inverted. The early universe was not a blank canvas. It was a crowded, bustling, hyperactive metropolis. And lurking in the hearts of these impossible, ancient galaxies, Webb found something even more terrifying: supermassive black holes. In the modern universe, black holes are the undisputed apex predators of the cosmos, millions or billions of times the mass of our sun, anchoring the centers of galaxies. But they are supposed to grow slowly. A black hole forms from the collapse of a single massive star, and then it feeds, consuming gas and dust, limited by the intense radiation it emits as matter spirals down its throat. This radiation pushes back against the infalling matter, creating a cosmic speed limit on how fast a black hole can eat. To build a supermassive black hole of 1 billion solar masses should take billions of years of steady, continuous feeding. Yet, Webb is finding black holes weighing millions of solar masses when the universe was less than 500 million years old. They are bloated, overfed, and entirely out of proportion to their host galaxies. They are cosmic anomalies that defy the known laws of physics. How did they get so big so fast? Did they form from the direct, catastrophic collapse of entire primordial gas clouds, skipping the star phase entirely and being born as massive singularities? Were the first stars in the universe unimaginably colossal, hundreds of times the mass of the sun, collapsing directly into heavy seeds of destruction? Or is there some fundamental, deeply hidden law of gravity and space-time that we have completely misunderstood? These black holes are not just objects. They are anomalies, glitches in the matrix of our understanding, whispering that the rules of reality in the extreme early universe were vastly different from the gentle, predictable physics we observe today. As astronomers reeled from the discovery of these impossible galaxies and premature black holes, they turned Webb's instruments to a different, equally profound question: how many galaxies are actually out there? For the latter half of the 20th century, humanity believed it had finally grasped the scale of the cosmos. When the Hubble Space Telescope stared at a tiny, seemingly empty patch of sky the size of a grain of sand held at arm's length, it revealed thousands of galaxies. From this, scientists extrapolated that the observable universe contained roughly 200 billion galaxies. It was a number so vast it induced a sense of cosmic vertigo. Felt like the final answer. Then Webb looked at the exact same darkness. Where Hubble saw empty, black gaps between the stars, Webb saw a teeming, layered, infinitely complex tapestry of infrared light. Galaxies that were completely invisible to Hubble suddenly blazed into existence. Dusty, obscured star-forming regions, ancient red galaxies drifting in the deep void, and chaotic, merging clusters that had been hiding in the infrared spectrum all along. In one of its most ambitious deep-field surveys, Webb captured a patch of sky that contained not thousands, but hundreds of thousands of distinct, ancient galaxies. When astronomers scaled this density up to cover the entire celestial sphere, the numbers ceased to make logical sense. The universe does not contain hundreds of billions of galaxies. Contains trillions, perhaps 2 trillion, perhaps more. For every single galaxy we thought existed, there are 10 more hiding in the dark, cloaked in dust or shifted beyond the reach of visible light. This revelation fundamentally alters our understanding of our place in the cosmos. The universe is not a sparse, lonely archipelago of matter separated by insurmountable oceans of void. It is a densely packed, hyper-connected, overwhelmingly crowded ecosystem. But this incredible density is not random. As Webb mapped the positions, distances, and masses of these trillions of galaxies, a grand, terrifying, and beautiful architecture began to emerge from the darkness. The galaxies are not scattered like sand on a beach. They are organized. They trace invisible, monolithic pathways across the void. On the largest scales, the universe resembles a colossal, three-dimensional neural network, or a cosmic spiderweb. Long, glowing filaments of matter, stretching tens and hundreds of millions of light-years across, intersect at dense, blazing nodes where massive galaxy clusters reside. Between these filaments lie the great voids, spherical regions of absolute, terrifying emptiness, spanning hundreds of millions of light-years, where almost no matter exists. If you were to float in the center of one of these great voids and look out, you would see nothing. No stars, no galaxies, no light. Just an endless, suffocating blackness stretching in every direction. These voids are the largest contiguous structures in the universe, born from the subtle quantum fluctuations of the Big Bang, amplified by billions of years of gravity draining matter away from these regions and pulling it into the glowing filaments. Webb has revealed that this cosmic web was already fully established, already rigid and structured, when the universe was only a fraction of its current age. The scaffolding of reality was built in the dark, long before the lights turned on. And threading this entire, unimaginably vast web together is a substance we cannot see, cannot touch, and cannot comprehend: dark matter. Dark matter is the ghost in the machine. It does not emit light, it does not reflect light, it does not interact with electromagnetism in any way. It is completely, utterly invisible. Yet, it outweighs all the visible matter in the universe, every star, every planet, every nebula, every cloud of gas, by a ratio of 5-to-1. We only know it exists because of its gravitational footprint. It is the invisible skeleton upon which the flesh of the visible universe is draped. Without dark matter, the early universe would never have clumped together fast enough to form the galaxy's web is seeing. The dark matter halos formed first, acting as gravitational traps, pulling in the primordial hydrogen gas, compressing it until it ignited into the first stars. Webb is effectively mapping the shadows of this invisible skeleton, proving that the reality we can see is merely the glowing tip of a massive, dark iceberg. We are living inside a haunted house, surrounded by an invisible architecture that dictates the fate of every galaxy, yet remains entirely beyond our physical grasp. But as we stand in awe of this crowded, structured, hyperactive early universe, a darker, more unsettling realization begins to creep in. A realization that strikes at the very core of what it means to exist in this cosmos. All of this, the trillions of galaxies, the cosmic web, the impossible black holes, the ancient light, exists only within a very specific, strictly defined boundary. We call it the observable universe. And the true scale of this boundary is the most mind-shattering revelation of all. For decades, popular science has told us that because the universe is 13.8 billion years old, and light travels at a finite speed, the edge of the universe must be 13.8 billion light-years away in every direction. It makes intuitive sense, feels logical, but it is fundamentally, catastrophically wrong. The observable universe does not have a radius of 13.8 billion light-years. It has a radius of roughly 46.5 billion light-years, making its total diameter an incomprehensible 93 billion light-years across. How is this possible without breaking the ultimate speed limit of light? The answer lies in the most terrifying property of the cosmos: the expansion of space itself. When we say the universe is expanding, we do not mean that galaxies are flying outward through a pre-existing, static void like shrapnel from a bomb. We mean that the very fabric of space-time, the stage upon which reality plays out, is stretching. Imagine drawing two dots on a deflated balloon and then blowing it up. The dots are not moving across the rubber. The rubber between them is expanding, carrying them apart. Space is doing the exact same thing. When a distant galaxy emitted the light that Webb is just now receiving, that galaxy was relatively close to us. But during the billions of years that the photon was traveling toward Earth, the space it was traveling through was continuously, relentlessly stretching. By the time the light finally hits the golden mirrors of Webb, the galaxy that emitted it has been carried away by the expansion of space to a distance of over 46 billion light-years. Light has been running on a cosmic treadmill, fighting against the very expansion of the road it travels on. This creates a boundary, a hard, inescapable limit known as the cosmic horizon. This horizon is not a physical wall. There is no brick barrier, no edge of the cliff where the universe simply stops. Space continues beyond 46.5 billion light-years. Galaxies continue to form, stars continue to burn, and civilizations might continue to rise and fall in the regions beyond our horizon. But they are permanently, irrevocably cut off from us. The space between us and those distant regions is expanding faster than the speed of light. Because nothing can travel through space faster than light, no signal, no message, no physical object from beyond that horizon can ever reach us. We are trapped inside a bubble of causal connection, a sphere of light that defines the absolute limit of our reality. And this is where the true existential horror of the James Webb Space Telescope's discoveries comes into sharp, terrifying focus. Webb has not just shown us how big our bubble is. It has shown us that the bubble is leaking, and the darkness outside is winning. The expansion of the universe is not slowing down under the gentle pull of gravity. It is accelerating. It is speeding up, driven by a mysterious, repulsive force that permeates the very vacuum of space, a force we call dark energy. Dark energy is the ultimate predator of the cosmos. It makes up roughly 68% of the total energy density of the universe. It does not clump, it does not dilute, and it does not fade. As space expands, more dark energy is created, which drives faster expansion, which creates more space, which creates more dark energy. It is a runaway feedback loop that is slowly, inexorably tearing the fabric of reality apart. Because of this accelerated expansion, the cosmic horizon is not a fixed boundary. It is a closing door. Galaxies that are currently near the edge of our observable universe are being pushed away from us at an ever-increasing rate. Eventually, they will cross the cosmic horizon. When they do, their light will become so infinitely stretched, so profoundly redshifted, that it will fade into absolute nothingness. From our perspective, those galaxies will appear to freeze in time, growing dimmer and redder until they simply vanish from the sky. They will not die. They will just be erased from our reality, carried away into the unobservable abyss by the relentless tide of dark energy. If this acceleration continues, and all current data suggests it will, then in 100 billion years, the night sky as we know it will be gone. The trillions of galaxies, the cosmic web, the ancient light, the evidence of the Big Bang itself, will all have slipped beyond the horizon. The universe will appear completely, utterly empty, save for the local group of galaxies gravitationally bound to our own Milky Way. A civilization born a trillion years from now will look up at a pitch-black sky. They will have no way to know that the universe is expanding. They will have no way to know that the Big Bang ever happened. They will believe, with absolute scientific certainty, that they are the only island of matter in an infinite, static, eternal void. The history of the cosmos will be permanently erased, locked away behind the horizon of dark energy. Webb is allowing us to witness the universe in its vibrant, chaotic, crowded prime. We are living in a golden age of cosmology, a fleeting, ephemeral window in time where the universe is still visible, still readable, still teeming with the light of its ancient past. We are the lucky ones. We are the generation that gets to see the cosmic web before the lights go out. But this privilege comes with a heavy, melancholic realization. The true scale of the universe is not just a measure of distance. It is a measure of our profound, inescapable isolation. Even within our observable bubble, the distances are so vast that they render physical travel, and even meaningful communication, completely impossible. The speed of light, which we once thought of as the ultimate connector, is actually the ultimate barrier. It ensures that every civilization, every star system, every conscious mind in the cosmos is marooned on its own tiny island of spacetime. If there is an alien intelligence looking back at us from a galaxy 10 billion light-years away, they are not seeing the Earth of today. They are seeing a dead, molten rock, or perhaps they are seeing the light of our sun before the Earth even formed. We are entirely out of sync with the rest of the universe. We are shouting into a void that will not hear our echo for billions of years, and by the time the echo arrives, we will be dust. Furthermore, the sheer, overwhelming abundance of galaxies revealed by Webb forces us to confront a deeply unsettling paradox. If the universe is this crowded, if there are trillions of galaxies, each containing hundreds of billions of stars and countless rocky planets in the habitable zone, then the stage is set for life to be ubiquitous. The raw materials, the time, and the space are all abundantly available. Yet, when we look out into this teeming, hyperactive, ancient cosmos, we hear nothing. No radiosignals, no megastructures, no artificial illumination. Just the blind, mechanical roar of physics and chemistry. This is the Fermi paradox, magnified to a terrifying scale by Webb's golden mirrors. The universe is not just vast. It is aggressively, overwhelmingly fertile, yet it remains profoundly, eerily silent. Are we the first? Are we the last? Or is there some invisible, universal filter, some inevitable cataclysm that wipes out civilizations before they can cross the interstellar gulfs? Webb cannot answer this question, but by revealing the true, staggering scale of the arena, it makes the silence that much louder, that much more oppressive. As we digest these revelations, we must also confront a crisis brewing at the very foundation of modern physics, a crisis that Webb has inadvertently deepened. It is known as the Hubble tension. When cosmologists measure the rate at which the universe is expanding, they use two completely different, highly precise methods. The first method looks at the cosmic microwave background, the fossil radiation left over from the Big Bang, and uses the standard model of cosmology to predict how fast the universe should be expanding today. The second method looks at the local universe, measuring the distances to pulsating stars and exploding supernovae to directly calculate the current expansion rate. These two methods should yield the exact same number. They do not. The early universe predicts an expansion rate of roughly 67 kilometers per second per megaparsec. The local universe measures a rate of roughly 73. This discrepancy is not a rounding error. It is not a flaw in the instruments. It is a fundamental, glaring contradiction in our understanding of reality. It means that either our model of the early universe is deeply flawed, or there is some unknown, exotic physics governing the local universe that we have completely failed to detect. Some physicists whisper that dark energy might not be a constant force, but a dynamic, evolving field that has changed its strength over cosmic time. Others suggest the existence of new, undiscovered subatomic particles that existed in the primordial soup and altered the expansion rate. The Hubble tension is a crack in the foundation of the standard model of cosmology, a glaring warning sign that despite all our golden mirrors and infrared sensors, we are still fundamentally misunderstanding the deepest mechanics of the cosmos. Webb was supposed to help resolve this tension by providing ultra-precise measurements of local stars. Instead, it confirmed the higher local expansion rate, sharpening the paradox and plunging cosmology into a state of thrilling, terrifying uncertainty. We are standing on the precipice of a new scientific revolution, realizing that the rules we thought governed the universe are merely approximations of a much darker, much stranger truth. Let us pull back, far beyond the Milky Way, far beyond the local supercluster, and try to hold the entire 93 billion light-year observable universe in our minds. It is a sphere of space-time, bubbling with trillions of galaxies, threaded by the ghostly filaments of dark matter, and being relentlessly stretched apart by the invisible pressure of dark energy. It is a system of incomprehensible violence and breathtaking beauty. Stars are born in the violent collapse of gas clouds, forging the heavy elements of life in their nuclear hearts, only to die in supernova explosions that scatter those elements across the void, seeding the next generation of worlds. Black holes tear stars apart, spitting out jets of plasma that stretch for millions of light years. Galaxies collide, merging in slow-motion dances that take hundreds of millions of years, triggering massive bursts of star formation and reshaping the very structure of space-time. And yet, amidst all this colossal, roaring machinery, there is a profound, chilling fragility. Everything we see, everything we can ever hope to interact with, is confined to this single, expanding bubble. Beyond the cosmic horizon, the universe likely continues infinitely, filled with structures and phenomena we can never dream of, governed by the same physical laws, but forever separated from us by the relentless expansion of space. We are like a person trapped in a small, illuminated room in the center of an infinite, dark forest. We can see the walls of our room, we can study the dust motes dancing in the light, but we can never, ever step outside, and we can never know what lurks in the endless dark beyond the glass. This is the ultimate legacy of the James Webb Space Telescope. It did not just give us higher resolution images, it gave us a profound, existential paradigm shift. It stripped away the comforting illusion that the universe is a static, measurable box that we can eventually conquer or fully comprehend. It revealed a cosmos that is dynamic, ancient, hyperactive, and fundamentally hostile to connection. It showed us that time and space are flexible, that the past is literally visible if you have the right eyes, and that the future is a dark, lonely place where the stars will eventually blink out, one by one, carried away by the dark energy that permeates the void. We are a fleeting, ephemeral spark of consciousness, clinging to a tiny, rocky planet orbiting an unremarkable yellow dwarf star in the obscure suburbs of a spiral galaxy. We have existed for a mere fraction of a cosmic second. Yet, through the sheer, stubborn power of human curiosity and ingenuity, we have built a machine of gold and beryllium, hurled it into the freezing abyss, and used it to look back to the very dawn of time. We have seen the monsters that lurked in the primordial dark. We have mapped the ghostly skeleton of dark matter. We have measured the terrifying acceleration of our own isolation. The universe is not empty. It is not quiet. It is a roaring, chaotic, magnificent engine of creation and destruction, operating on scales that render human concerns utterly insignificant. But there is a strange, profound beauty in this insignificance. We are the universe experiencing itself. We are the mechanism by which the cosmos knows its own scale, its own history, and its own inevitable fate. The light that hits Webb's mirrors has traveled across the expanding void for billions of years, surviving the birth and death of stars, navigating the gravitational labyrinth of dark matter, and stretching through the relentless pull of dark energy, just to end its journey on a detector built by creatures of dust and water. In that single, miraculous intersection of ancient photon and human technology, the universe achieves a moment of self-awareness. We are marooned on our island, yes. The horizon is closing, yes. The ultimate fate of the cosmos is a cold, dark, isolated eternity. But right now, in this brief, golden epoch, we can see the tapestry. We can read the archive of the stars. We can stand on the high peak, look up at the glittering dome, and understand, with terrifying clarity, the true, staggering, heartbreaking scale of the reality we call home. And perhaps, in the face of such overwhelming, incomprehensible vastness, the most shocking discovery of all is not the size of the universe, but the fact that we are here, against all odds, awake, aware, and brave enough to look into the abyss and ask it for its secrets.